So the first thing, as we start getting back in here, I'm going to figure out so we can walk through the steps together here. So to get started this morning, we need to be back in our Unidata Python Workshop directory. Of course, reactivate the Unidata Workshop environment. Oop. Ah.
My directory has disappeared overnight.
I did not nuke anything.
I didn't nuke anything either. You're on the lab machine?
Yeah, I'm on the same sheet I was on yesterday.
Well, you did some stuff.
I fixed some things. I didn't blow anything away. I don't think. That's weird. All right. So for those of you on laptops, you're on machines, and if you run Python-C quote import netcdf4 quote.
The environment.
Yeah. Oh, even I'm seeing that one now. Fun.
What's the command Python-C?
Python-C. There we go. I think I can get this.
How do I get the Unidata Workshop environment?
Source activate Unidata Workshop. That should work for you.
I'm getting the same error I got.
Okay. Not surprised. So, no telling what this is going to do on my machine because this was working yesterday, so I'm not clear why I'm getting an error now. But to fix it on your laptops here, if you're getting the error you saw yesterday, we should be able to do Honda config -- add channels on the Forge. I already have that one. And you guys should then be able to do conda update HDF4.
I'm getting an auto question packages already installed.
Okay, so if it's still erroring, conda install -- force HDF4.
It's installed, good, right?
The important part is, does importing netcdf4 work or not? Okay. So I mean, if you can import netcdf4, you can relax until we start opening notebooks again. Just trying to get back to a point where people can work with netcdf, since we will use that library later today. So you.
I just did before, and I'm still not able to import.
All right, let me take a look. You're on a Mac. So you might be seeing the same thing
I'm
I'm
doing the same time.
seeing, which is weird.
It's only a, it's only a per. Per session. Oh, this isn't good. What do you got? Well, I did the HDF4 with my concept. It's a listed file with this environment.
What do you mean? Conda, you don't necessarily have to have Conda installed in the environment. That'll
You
be
can source
alright.
activate from well, but
Can you run that Python space that quote
and now you can
import
your
space
Python.
lowercase any or good enough for me.
Yes.
Half an
But that'll
hour.
be good. But what's next to be important to install?
What if we just do Conda?
Okay, so I guess that's still.
Okay.
Well,
So
so
your
let's
problem-
try that. So if you say, well, no, let's do.
I
let's do
have to dig myself out of quite a few holes.
Just say Python.
So we're gonna deactivate the environment.
Import and the lowercase net.
Remove the Unidata Workshop environment.
Lowercase net.
We should still have all the unit.
Okay, so you're fine. You're good. Okay, so you can control D to get out of there, or
You still have in your downloads, your menu.
open parentheses. So now you can do vector.
So every time I
Turn it up.
computer and
It's not hard.
Yeah, switch to bash. Switch to bash.
This is the
Activate.
packaging bug that Conda formatting kind of like
so the
accidentally overwrites
will have a directory.
Conda itself.
Wherever you type that command, then that's where the notebook's going to start.
When you, at some point,
you can go
there's
to a
anything
directory
went horribly
and
wrong with the
notebook.
HDF5
Open up,
package.
and with that directory.
So keeping a notebook is like self Python but using a
Yes.
Oh.
So it's setting up a mini
Okay,
web
so-
service.
You're probably seeing the same issues.
Use your browser to talk to it.
Oh.
So what's the,
Yeah.
yeah, and then what happens, so if you source deactivate,
Sean, try to blow away the environment, but if you can't, you might need to reinstall mini content. This is the HDF5 problem. Yes.
all of mini content?
Yes. The package update went so bad, it accidentally overwrites content itself. Parts of it. They had a big bug yesterday.
Do I have to reload it?
if you're working, you're good. I don't know why you're good, but you're good. It's all working. So. Run it, yes. They did fix it, but I don't think it's recoverable. I think once they blow away whatever the file is, when I can't run like Conda remove my environment, I'm just kind of, that should never happen. We need to edit your profile like it's not, you already did that, right? Yeah. Unidata Workshop, Conda, downloads. All right. Okay.
That's pretty quick to get yourself back.
So you can go to your downloads.
You do Conda space env space remove dash n Unidata dash workshop.
No, we have it. Sounds like it's just.
Oh, that one, you're not for, so that's lots of it. Go ahead and say yes. Don't keep your download cache. You're in your Unidata Python Workshop, so if you do Conda env create, just the use method, set up the file, paste, create the environment. I don't think you have to download much. So that one had an update. Here's an HDF5 update, that's good. Control that Wi-Fi. Oh, well, I just meant it's killing what you I just meant it's killing the Wi-Fi that everyone downloading, my bad.
Take these very literally.
Yes, yeah, no, that was my bad. That was absolutely my bad.
Maybe you wanted it to just download from the cache.
No, that would make sense. I understand what you're saying. Okay with that. Brilliant. As I'm telling everyone to re-download things, we're just going to bring the Wi-Fi to its needs.
Right.
All right. Are you having problems?
It updated to 3.5 and it says site.
Yeah. Did you go through the default installation? Were you here this next online?
No,
Okay. See what we got. That's so weird. You could keep that in one. Oh, really? We did the create or what is it?
I haven't done that yet.
Okay, yeah, that's the person, that should actually take care of installing everything.
Oh,
It's
really?
like, yes. So I need to clarify your instructions.
Okay, no, that's
Goes to condy and be create, yeah. That should just go download a bazillion things.
So you don't have to.
That's okay, it needs to go to Prometheus and Prometheus.
I use.
Yours should be good. You guys said we're all good.
I mean, I looked through all the computer notebooks. There was a bad showed up on and it didn't happen on Monday. No, because it still happened on Tuesday. They had a bad bill yesterday. Do you know which bill?
It's either all together in one binary. Yeah, Unidata Workshop is a name I wish it worked the way you type it. That's right.
So actually we want to add the channel.
He's all right. It's in the environment file, so you just do condy and create other things.
Not fix it.
Anything that's already done.
You have homebrew on there. So brew list, brew.
Trying to run through my days.
Okay, you have homebrew.
Right. This what?
HDF5.
Right.
I can't see what you want.
And then go back to.
So that install.
Is it a regular? It's fine.
I have NetCDF there. I forgot about that. You go back in there. So. Oh.
Picking up some. Well, that one works. I don't think so. This is the worst I've ever seen.
Something great.
Yeah.
Too many tip files, you know, these fun stuff, so.
Well, I'm got a different problem here.
I'm somewhat used to, if I'm doing it by hand, HDF5 being out.
Yeah.
A lot of times it turns out it's like.
The number of warning and error messages that come out of that thing are just
Yeah.
enormous.
But I figure if I can run the NetCDF
Only to work the way you need to, yeah.
if I can do a make chat like you want to, yeah, passes and say, all right, enough of HDF5 is probably okay.
That's a good question. Well, this is, he's got a, picking up the wrong version of HDF5, or picking up something that's probably is an old HDF5. I don't know what.
Load library.
I might have a,
Is that something in your patch?
yeah, probably.
Check that, see, okay. So,
Load library patch.
I want to check those real quick.
I like to explain what's in my desk.
You could just do ENV. ENV will give you the full listing. Easy something that.
Yeah, because I was running,
Yeah, set some load library paths. And so the easy thing, the easiest thing to do is to figure out which variable that's going to say. And then,
do you think it's the NetCDF library?
no, that's
Well,
specific.
Let's see if library can be the one doing it, at least you're not seeing yours.
No, no,
He's
no.
getting it. You should be
NetCDF,
good.
there's an environmental variable called NetCDF.
Okay.
And that's.
All right, I'm gonna fix mine, and if you could help him work through that. All right, let me fix my computer real quick here. What? Oh. Okay. So we're, yeah, let's get going here. Jesus. All right. All right. So we can start trying to get going here. We just lost a little bit, but that's okay. So you've got your environment active. Let's go ahead and start our notebook servers up again. That's Jupyter Space Notebook.
Sweet. That's what that was succeeded before.
Oh, what was found here, like the data set?
All right. And so we're going to come over here to the notebooks directory and bring up this notebook called Pythonic Data Analysis.
Oh, yeah.
And so the goal here is to just try and work through some of the more intermediate features of the Python language and try and show, how you could maybe exploit some of those for shorter or at least, maybe improve your data analysis scripts, I guess is the way I'd put it. And just make you aware of some things that you couldn't. Even before our technical difficulties, I didn't intend to get through this entire thing, but we'll get through as much of it as we can. And then it's here. It consists of a lot of, examples and then, really open-ended exercises.
I just got a dead kernel warning.
Woohoo!
And it says try restarting, and then it's dying. So
Are you running any cells when you do that?
no. I just pulled up the notebook. Does anyone else have this?
Only when I try and run the first, so.
You, I understand. You got one.
So I didn't think I was trying to write anything.
It shouldn't, if you're just bringing up the notebook, it shouldn't.
Okay, can you go to the terminal where you started your?
So, and just,
I
Oh.
don't know.
So for reference when we,
Okay, so
since we won't get through this entire one, the
Control C that.
solutions, as it were, to the exercises we do in here, there's a separate notebook that lists the code, at least I was planning on writing for some of these. So, if we don't get to everything, you still have another notebook here that can show off at least what I was intending, and you can use that as a reference for some of these more advanced things.
There's a setting in terminal that says if there aren't any processes running associated with this terminal, go ahead and close the window. Or you can close the window manually. Okay, so you're in your unit.
So-
Okay, so now you.
Some of the things in the language we'll talk, or at least they're on board to be talked about here, were some things about iteration unpacking. So looping over a list in Python or multiple lists of things and being able to unpack those multiple things conveniently with
Oh, I won't do it.
Python's unpacking syntax. Then we have
Now let's see what happens.
dictionaries. We'll talk more about them and how we can use those to simplify code. First class functions, we may or may not get to that. I'm going to guess not now, but that basically means you could just pass around functions as you would any other variable and call them. So unlike the horrible machinations you might go through in C and C++ to work with pointers to functions, it's really easy to just pass around a function in Python and then call it. So it allows you to really kind of factor your code in a way that you could just have a function that takes another function and calls it within there, and you don't have to have these two things tightly coupled. You could just, if you wanted to make a function that smooths your data in different ways, then you can write an analysis function that just takes a smoother and calls it with your data, and it doesn't actually have to know any more than just I need to give it an array of my data for it to smooth. So it's kind of that kind of way of being able to break down your code. And then the other thing I was, having this notebook is looking at some file path manipulation. So just easy working with names of files and listing directories and using wildcards and finding, maybe all the netcdf files in a directory. We probably won't get there, but I just want to make you aware that the Python standard library has a lot of tools for doing things like that really make it easy to write a Python script that, maybe generates an image from every netcdf file in the directory or something like that. So, moment of truth here. First thing we're going to do here is use netcdf, as Sean showed yesterday, and use it to open a netcdf file with GFS model output. I'm waiting to see people to see who decides to have their computer explode now.
This kernel is saying that your notebook's not trusted. I've never seen.
That's normal. That's okay.
Okay.
They added some trusting for you can sign notebooks and
then he's getting some actual errors from the notebook kernel, but it's not restarting anymore.
okay. Call it good. If you can execute the code and keep going, then we'll call that a victory for this morning. All right. So then after opening data set, we pull out the time variable. And then I go ahead and use that num to date function we saw yesterday to convert those values to date times. So real quick,
Do you know ahead of time that you have to squeeze it, get rid of the dimension when you do that?
no. Usually I go to plot and get an error from Matplotlib complaining about the dimensions of the data and just go back and say, okay, give me a squeeze. I mean, you can look at it and say, if I run that, I see the shape's 1/24 and say, okay, that's probably gonna complain, so I'll go ahead and
Okay.
throw on a squeeze.
If you squeeze when you don't have a dimension, you squeeze out, does it error? Is it
Nope.
just not doing that?
Doesn't do anything.
So you can put it on and,
Yeah.
oh, right.
So the only cost of putting squeeze on there is the extra typing and maybe making your code more convoluted. I certainly start to get a little sad when I look at, if I have 10 lines that all have squeezes on it, it's like, something's not right here, but it's an easy hammer to use. So I want to make a simple time series plot with Matplotlib. So what we could do here, and as I look at this, I don't like this one line here, so I'm going to actually take out this line with the variables and the squeeze. Just make it a little easier to reason about. Say temp equals that. The data variable is temperature isobaric. So pull out the data. Now the data, we pulled out the time already. Now we're pulling out the temperature data or temperature forecast. Then here's our call to make a fig and axes. We plot on the axes time, and I need to type in here temperature. I say, let's make that a red solid line and add a grid. So nice and easily, I've got a time series plot. You see down here, the default ticking here, it decided that it's just going to label the time, it seems. So I have 012, 012, 012. That's not particularly nice. I have no idea what dates we're looking at here. So we can look at a bit more customization of what the ticking looks like here. So for a time series plot, we might actually, we should put some more work here to get good times printed out here. And Matplotlib has good support for doing, handling these date times and plots. We just need to give it some help. So here's the same plot commands. And then I went ahead and added, set up the font size and setting the X and Y labels. And then down here now we're starting to work with how we format the ticks. And so ticking in Matplotlib has two different knobs you can use to customize. You have what Matplotlib calls a locator. And what that does is that controls the location of the ticks. What values do you want to have tick marks for? And tick marks aren't just, it's the tick marks. That affects where it puts labels for tick marks. That also affects where the grid lines will be on the plot. So it's all those things come from the ticking, as it calls it. And the locator just controls what values end up with the ticking. So for a basic plot, you can use this to say tick every 5 or tick every 10 or tick these specific values.
Instead of using that day locator call, if you set the major locator to 5, would it just do check marks every 5?
No, you have to give it. So we're importing these locators from the dates module. Instead, you would do something like from matplotlib.ticker, import multiple locator.
Okay,
And then you do multiple locator 5 in here.
got
So the dates library within Matplotlib has functionality specific to working with dates and times. So on the axis object, we get the x-axis attribute. So the axis has attributes for both the x-axis and the y-axis. And on the x-axis, we call set major locator. So that's setting the tick locator for the major tick marks. So you can have, actually, it has a notion of major tick marks and minor tick marks. So you actually have two different levels here. Circling back around and finish there. So the first part's the locator. That controls where they go. Then you have a formatter that controls how does that text look? What's the string formatting of the tick marks? How do we want it to appear? And so on the x-axis, we also set this set major formatter. And we give it a date formatter, and then we pass these mystical, weird-looking codes. Well, what are those things? So if we go looking for docs, we can say Python, date time, string f time. And there's really no way I can say to make this discoverable other than knowing string f time, strf time, is the string format time function in Python. So if I go look for that, top link, already purple because I've come to this page probably 24 times in the last 6 months because I could just never remember exactly which one of these, is the right one. If we come down here all the way to the bottom, string f time and string p time behavior. And so we have all these percent directives that give you different ways of pulling out different pieces of the date time. So, we have the month in your current locale, so your current local environment. So if you had foreign language months, they could be used through here. We can get the day of the month, the zero padded number, get the minute, et cetera, et cetera. So all these codes are different ways, different information we pulled out and control how it's formatted. So over here, I decided to go %B, %D. Well, % lowercase b is this one. So I did the month abbreviated. So JAN, FEB, D, et cetera. And so here's the thing about the locale. For instance, in English US, we get, December is DEC. In I actually don't know what locale that is off the top of my head. I'm going to guess maybe Denmark. December is DEZ. And then we also did %D, I believe lowercase d, and that's this one. So we get the day of the month with the leading 0. And so that's what we use here to control the format of the dates. So that's the major ones. I also want some minor tick marks here. And so here I can set the minor locator, and I want to put ticks for certain hours. I want to locate 6, 12, and 18. So I could have just given it a list here, and that might have actually been clearer. I used a range. I'm actually going to change that here. So I'm going to say 6, 12, and 18. You don't actually need to change it. I'm just trying to make it more clear what's going on here. So we're going to locate tick marks at the hours of 6, 12, and 18. And then I'm going to set the formatter. It's another date formatter. I'm giving it %H, capital H. So that says over here, 24, the hour on a 24-hour clock as a 0 padded decimal number. Good. And then I have it put a Z after it. So it looks like 18Z. So if I look down at the figure here, there's July 18, and then 6Z, 12Z, 18Z, and then July 19, 6Z, 12Z, 18Z, etc. For the lines here, I call grid, but before we just said true. You can be a bit more specific here and say, okay, we're just talking about the grid along the x-axis. And by default, it'll be talking about the major grid. So for the major tick marks, I'm going to dash it. I'm going to give it this particular grayish color and set the line width to 1. Then here, I'm just saying, turn on the minor grid lines for the x-axis and turn on the major grid lines for the y-axis. So that's what gives us this resulting plot. Nice day markers here as we go through the time series. And then we also have ticks for each of the hourly forecasts. So it's gone quite a bit deeper into your Matplotlib customization, but you can see there's a lot you can do here to make things look better than the defaults. And regarding defaults, actually, I should mention, so Matplotlib's coming up to a major 2.0 release, where the big change here is they're changing the default styles. And so what that means is, the previous look was focused a lot around MATLAB compatibility. And so things like the default color map and things were all, matching MATLAB's defaults. With 2.0, things are supposed to be a bit more aesthetic. We have better looking plots by default out of the box. And since that's going to break the plots everyone has come to expect, is going from 1.5 to 2.0, but all they're changing there is just the default look of the plots. So I'll just put that out there. And then it does have the hooks in there. If you want to change the style back to the old defaults, you can do that. And they actually have a whole infrastructure for creating these style sheet things.
And easier to change fonts.
In that one, have they done anything about that? No, but with the style sheets is probably the easiest way to set up the fonts you want in one place as a style sheet instead of configuration. And then it should be used whenever you specify that style sheet, which really is easy as saying, now if you, for instance, with the once they go to 2.0, we could say lt.style use classic, and that'll get me the old look versus the new look. But if you created your own configuration to spec out what your plot should look like, you could just set it up here and say use that style. And they do ship with some defaults. I don't actually know next to nothing about those other sets of defaults. All right, so that's just going into showing you a bit more of what Matplotlib has, especially with I really like the fact that it can handle dates and do a lot with those, since we often looking at time series data. So any questions about that? All right.
I'm sorry.
Go ahead.
The DICT command, the dictionary.
Yes.
I know you mentioned something about it yesterday. Is
That
an imported?
No, that's built into the language itself. And if you'll give me 10 minutes, we'll come up on these. It's kind of hard to start talking about Python without mentioning them, but I've kind of been skirting around it thus far, but they're really core to the language. All right, containers and iteration. So Python has built in to the language lists and tuples. So the quick and dirty explanation is it's a read-only list. So why would you want a read-only list? Well, one, the semantics of a tuple are a little different. There's a little bit more to it. Think of it like a structure in C, where the order of the fields, a tuple can be heterogeneous, or a tuple is more often heterogeneous. I mean, a list can be heterogeneous too. You can stiff whatever you want to in a list in Python. But you're more often to see a tuple that's heterogeneous, where the first item is always a float, two floats representing X and Y, and maybe the third item in a tuple is a string representing the name of the city or something. So if tuple's kind of a struct without named fields, if that makes sense to you guys. The other reason a tuple exists is because you can't use, when we talk about dictionaries and mapping, you can't put a list as a key in a dictionary. So you can't look things up by a list. But say you wanted to have a dictionary that stores pairs of integers. You want to make maybe something that acts like an array, but you don't have all the space that an array would take. You just have a couple points in this grid you want to put, and you want to just store it in a dictionary so you can look it up by a pair of integers. representing the array index. You can't use a list for that because you can modify the list and that would break the dictionary. So you put a tuple in there instead and it's read-only, and then you can be able to do that same thing. So those are the reasons why tuple exists. It's kind of very nuanced from what a list means. And I think we'll see some of these right here now.
So to be sure I understand it, tuple, you can't change the values, and a list you can.
Yes.
Okay.
You can append to a list is the big thing. You can just say, keep tacking out things at the end. You can't append to a tuple. You can create a new tuple and from the old one and add a new item to it, but you have to make a new one, whereas a list you can modify in place. From working with them, that's the big difference. It's the why would you use this versus this that's very much more nuanced. So what I've done here is I have one list I've created with the values 1, 2, 3, 4 in it. And then I created a second list with the string names of those. You know, the word 1, 2, etc. So one useful utility we have for working with lists is zip. And what zip will do is it will, whatever, you can pass it one or more or two or more sequences here. Not sure what would happen if you passed it one. Pass it a bunch of lists, and it will, what they call zip them together. So it'll take the first item from each of these and return it in a tuple, and grab the second one from each of these and return it in a tuple, and the third one, etc. So if we look at what happens here, I print Z now and run this cell. What did it do? Okay, so we get a new list here, denoted with the square brackets. And the first item in this list is a tuple. That's how you can tell it with the parentheses here. And so it pulled out the 1 out of names, and then the value 1 out of vals, and the 2 out of names, and the 2 out of vals, and onwards to 3 and 4.
So, I'm sorry about this little thing. The
No.
tuple has the parentheses
Yep.
on the square bracket.
Correct. Tuples, parentheses.
So I was playing around here. I was Z at 0. I was able to modify the tuple. I was able to modify the values.
Well, if you modified Z, you're replacing the tuple.
Right. Is it because it's within a
So here, okay, so Z is a list.
right?
So Z0
Because
is,
you made a list of tuples, you can replace a tuple within a list.
you can replace you can replace the item within the list.
Okay.
But see, notice if I say, okay, I can say Z01. So I'm going to get the first item here. And then, actually, I'm going to go and get Z00. So that should give me the word 1. Right? So what if I wanted to say, uno?
Okay.
So I can't modify the tuple that's in there. I can replace it. I can, do all sorts of things with lists. But as far as the tuple goes, you shall not change it. So far good on what zip just did there. Okay. So I'm going to try a different tack here to try and keep this from getting confusing. So Python functions can take an arbitrary number of position arguments. So if we made a function, maybe the function get my args. We could say A, B, C if we knew it wanted to take 3 arguments. But instead, if I just wanted to take however many, I can give it, I can say start args. That means here's a function and it can take however many arguments position as I want. Yes. Sorry about that, guys. And so what I'll do here, just say, well, for arg in args, print arg. Real, not particularly sophisticated, but I want to get across what we're doing with passing multiple position arguments. So I could say, call get my args with just the number 1. It only gets one argument, and it prints out the 1. I could call get my args with 1, 2, 3, 4, 5. I'll get my args with a z. And notice on one line here, so it only called print once. It grabbed the list and just printed out the whole list. Other than maybe not seeing the point of this exercise thus far, are we at least with me on what it's doing? Okay. So the reason I'm trying to get away from this being confusing is because the next one might be a little weird. We can, if instead of just passing the list, we wanted to take each of the items in the list and pass it as a parameter to the function. We could say get my args star z. So here, we just pass the list as a single parameter of the function. Now I'm saying take each item in the list and pass them individually as positional arguments. So if I run that, now we're back to getting 1 print for the first item in the list, 1 for the second, 1 for the third. All that's a prelude to lead up to, we did this zip earlier. So we combined 2 lists into 1, creating items. If you want to go the other way, so we have 1 list that has these groups of items, and we want to split apart those groups into a list of each of the individual things. So if I wanted to go backwards and say, I want a list that just has the first item from each of these, and also have a list of the second items by themselves. That would be, unzipping it. This is how you unzip it. And so now we've gone back from z being this to now having them split back apart.
What's going on under the hood there. If you're using, so if star z is just giving you 1 element at a time.
1 element at a time from z.
Right.
So that's the same as doing, let me put this back up there. Zip. So we're passing 3 different, so we're passing each of these to zip. So each one of these is an argument, and we're basically zipping these 4 things together. And so then zipping the 4 together means it's going to take the first item from each of them, and then it's going to take the second item from each of them. 1, 2, 3, 4. It's just one of those tricks I've seen many times, oh, I use zip. Now, how do I go backwards? And sometimes it can be a little hard to find. I don't know, maybe Stack Overflow's got it so it's easily searchable now, but I always found that one a little interesting. Of all you do is add the star there basically, and it unzips it. So with the containers here, one other useful part is unpacking. So start here, let me print vals. Okay, so what we can do is in an assignment, we can put multiple things on this side, and it'll pull out the corresponding items on the right side. So vals is a list of the integers 1, 2, 3, 4. So if we want to assign those to individual variables, we can just put 4 variable names on the left side and say that equals this list of 4 items. That one's one of my probably my biggest favorite of the Python features, because that allows you to do things like this down here. You can return multiple values from a function. And so if I had this polar to Cartesian function that takes the radius and theta, we can within that function return both x and y from the calculation. And so we can call it and get them back and put them into separate variables here. X comma y equals polar to Cartesian. So it'll pull x into x and y into y.
So if you only have one return value, x equals polar to Cartesian, x is a list then of those 2
Yes.
values?
Technically, I think it's actually a tuple. Because under the hood, what you're doing here is this creates a tuple. It returns the tuple. This unpacks a tuple. So that kind of powers things like this. If we want to loop over multiple lists together, so if I have a list of names and vals here, I can do a for loop. So realize I haven't really explained for you. Those of you new to Python, there we go. Now this is how you write a for loop in Python. For, if we wanted to count integers, for I in range 5, print I. That's your basic for loop in Python. Again, using the indentation to denote the block for the for loop. You actually can't use the for syntax to write a C style for loop. You could use a while and get close, but looping in Python generally is for an item in some kind of sequence. So range creates that sequence for you, and then you're just pulling ones out of that. So to loop over more than one thing, we use that same unpacking stuff, and we can zip the sequences together that we're looping over. So we can zip names and vals, loop over it, extract it, each item here, and print it out.
So in this case, like, it's a pretty simple list. Right?
Yeah.
Would this be faster than, like, let's say you have 1, 2, 3, 4 enumerate? So your list is 1, 2, 3, 4 written out. That makes sense. And then you enumerate. Is that slower than zip or does it matter?
The advice I've always had given, whenever you read a book on Python, is enumerates faster than. So, and I'll explain enumerate to the rest of you guys in just a second. Enumerates faster than doing a range and then using that to index into each of the lists. So enumerate is another way to do this. So if I say, We have names, right? So we could do for name in names. Print name. Okay, and that just prints each of the names one at a time. If I wanted to get the index along with that, a good way in Python is to use what's called enumerate. And so what enumerate does is we just, when we do our loop, we say enumerate. I learned how to spell enumerate. Wrap around names. So instead, that gives us both the index and the item. So we can print out index and a name. What did I do? Notice now it turned green. So index 0 is the string 1. Index 1 is the string 2, and so on. And this is supposed to be quicker using enumerate than using range and then indexing into the names list. Have I lost anyone on all this iterating and zipping and stuff? Or at least it's a little clear. I mean, you have to really write some code with this to really get used to it, but I promise it does feel nice after a while. So I had an exercise here that's pretty open-ended, and we're kind of crunched on time. So I'm going to walk through this with you because I also want to get to dictionaries before we close this one out. So here I just made a function just to quickly set up my plot. So it's a function, it takes an axis, and it calls all those functions we called earlier to set up the axis how I want it to look.
Yeah, really quick question on that.
Sure.
Why don't you have to return anything out of that function? It'll just set everything on that axis. And
Yep.
You can call it again anyway. You can call the show command afterwards without actually returning the axis.
Right. So this is modifying the axis object.
Yeah.
So we pass it in. So it's doing the work. Axis is this object, meaning not only does it have functions we can call, but it also holds on to state about the axis we're plotting on.
Okay.
And so this is modifying that directly.
Okay, so then you can just run it on that, and your axis object will still be there, but it will have the new.
Exactly. So we're kind of reaching into the box that is the axis, twiddling things in there and leaving it. And we already, outside this function, we already know what axis is.
Right. Okay, thanks.
Mm-hmm. So I'm just making that function. We didn't actually do anything there. And so what I'm trying to do is the goal is adding relative humidity isobaric as the second subplot here. So we've kind of, I think I've shown some of you, we haven't actually formally talked about this, the subplots making multiple axes on a plot. And so we've usually done subplots 1, 1 for one row, one column. Now I'm gonna make a 2-column plot. So here I say subplots 1, 2. And what that does is, right now, this is what it does. It gives me these 2 panels. So axes is actually a list. I think actually it's a NumPy array holding axes. So now I have a list of 2 things. Also, then, okay, maybe we have some variables we want to loop over now. All right, so if I put those in lists, then I could just do something like this. For var name, ax in zip variables, comma, axes. Ax.plot. What do I call my data set up here? It is called data. All right. Data.variables, actually time. Data.variables, var name. Put the empty slice there to get the data out of the file. Yes, sir. So just read whatever variable name we're currently plotting out of the file. And then also set up our defaults on that axis. So the nice part about setting up the plot that way is we haven't duplicated a whole bunch of code across two separate plots and don't have to go update multiple places if we want to change how we do the grid lines, how we do the ticking, the labels, and whatnot. I mean, we haven't labeled this plot at all on the y-axis, so we don't know which one's which, but you know, we could use that same var name and say ax.set ylabel var name.
A lot of different colors for those.
So one way I do this right now is I might do so a red solid line and a green dash line here. Add this to our zip. Now, there's a limit to how far you can take that. So real quick, that's where I might use dictionaries. So before I go down, everyone happy with that so far?
What is the value of access again in that?
So axes, let's take a look at it. Actually, let me put one below here so we don't redo the plots. So if I put print out axes here, it's actually an array. You can think of it as a list.
You're just pairing those with
Exactly. It's a list of each axis object. It gets a little more complex if we actually had like a two-dimensional set of plots here. Then it actually would be a 2D NumPy array of axes. And this is roughly equivalent to what's in the solutions notebook. So if you don't get this here, it's over there. So real quick on dictionaries.
I'm sorry, I'm not getting the line styles. Can you just go?
No worries. No worries at all.
Just for a minute.
Well, that gives me time to collect my thoughts on doing dictionaries in 5 minutes.
Are you gonna do the plotting in the dictionary?
Yeah.
Okay.
Good now?
Yeah.
Sweet. All right. Dictionaries. So that's another powerful built-in feature to Python. And so I just want to mention those. I'm not going through this whole section here because it gets into some nitty-gritty details using them. But dictionaries are probably my second favorite here, just because it's so easy to create a mapping between two different things in Python. So if I come down here into this section, it's really easy to say, I want a dictionary that maps, well, maybe I want one that maps states to their abbreviations. So I can make, yes, thank you. So we use the dict. We can use either the dict function here, and that creates a dictionary. You know, we could say Kansas equals KS, Oklahoma equals OK, Wisconsin equals WI. Or you can use that curly brace, as it shows right there. So actually, that is literally the syntax you'd use to create that dictionary. This way. The limitation of using dict like this, at least explicitly listing each of these arguments, is that these can only ever be strings. You couldn't put integers or whatnot, whereas here you can pretty much use anything with the exception of things like I said earlier, lists and other things you can modify. You couldn't put a NumPy array as a key here. So the left side of the colon is called the key. The right side is called the value. So I've created this thing, but what good does it do? Let's save this as a value. State map. Or state abbreviations. There we go. Now if I want to look up, okay, what is the state abbreviation for Kansas? Do that. You have this ability to do these kinds of things in C++. You could code it up in C, but that would be horrible. But in Python, 30 seconds, you have a dictionary that makes it easy to map two things together. And dictionaries are actually used throughout Python. So their implementation within the language is as fast as they can make it. There's probably been more optimization effort put into Python's dictionary implementation than probably any other part of the language, because it underpins a lot of other things like attribute name lookup and things like that. So when you do a dot something in Python, that's actually becomes a dictionary lookup. So the entire language is built upon these dictionaries. Now for, yeah.
When you're doing keyword arguments, when's the best time to use it? Because it's kind of like, I feel like keyword arguments are like, oh, whatever, just give me anything. And some things take very specific things. You want to generally show the person that is using your code what you're expecting, or because it's going to go into something else that has some words specifically use keyword arguments, let use that non-specific words.
So, right. Are you asking when you're using a function or writing a function?
Writing a function.
So writing a function, in Python 3, you can have keyword-only arguments. Whereas in the rest of the language, like Python 2, any argument can be either positional or keyword, which kind of complicates things. I've seen a lot, basically you boil it down to what are your main arguments, and you make those just positional. And then anything that's kind of like optional tweaking things, those, if you're using Python 3 only, keyword only arguments are a good way to go, because then you can add those without breaking your.
You would specifically write them out rather than just doing like star KWR.
Yes. Yeah, so star KWRs. So that's, for you not familiar, that's basically taking an arbitrary set of keyword arguments. Just like we did arbitrary positional arguments, you can take an arbitrary set of keyword function arguments. When we say, function blah equals, that's a keyword argument to the function. Matplotlib uses a lot of those arbitrary keyword arguments all over the place, and it makes the code very prone to weird errors. There are times when you kind of need that flexibility, but if you don't need it, write them specifically up there. And when you're calling functions, when it's not obvious what the parameter you're passing to a function is, use the keyword equals when you're calling the function. Like when I do the plots here, that's a really good example. You know, I plot with X and Y because that's pretty obvious to me. I use the style here, but you know, I could do line style equals. Well, this is not a good one because I don't have that. But if I was to call plot here, I'll start from scratch. Ax.plots time temp. And if I'm writing this, you know, in my own code, I'll say line style equals dashed color equals red. Thank you. And that way, when I go back and read this later, I'm not wondering what the order of the arguments here is. Granted, red and dashed are pretty unambiguous, but you can see for some code, this makes it a lot more readable without going and plunging into documentation what the function's doing. So the reason the keyword arguments comes up when we're talking about dictionaries is just like we could pass a list and unpack that as the positional arguments, you can use a dictionary for the keyword arguments. So real quick, I redo that plotting example, and I'm just going to copy and paste here. So here's that same plotting code we just did. And we did the line styles, and we used the MATLAB-like syntax. But that, you know, what happens if I just want to change part of it? It's not very, you know, extensible. So instead, I can use a dictionary here. In fact, I can use a dictionary and be able to just specify on a per parameter basis what the line style should look like. So we use this curly brace, temperature isobaric. And what style do I want for that? So I'm actually going to put another dictionary here of the style parameters. So I'm going to make the line width for temperature nice and thick. We'll overdo it and do the 3. And we'll make the color red. And we'll also do relative humidity isobaric. Go to dictionary of plot parameters. This time we'll do the line style dashed and the color dark green. So I have a dictionary now mapping the name of my variable to these other keys and values describing how I want the plot to look. So within this loop, I actually don't need to iterate over style. And that wouldn't necessarily make sense because dictionaries don't have an order. They're by the basic dictionary in Python is not sorted. It's not in any order. So if you loop over it, you don't know what order you're going to be pulling things out of. So instead, we'll just loop over the variable and the axis. If I want to get the style out, we can just say style equals line styles square bracket var name. And I've pulled out, for whichever variable I'm looping over, I've pulled out the appropriate style out of this dictionary. And if I want to plot using that style, given the dictionary with this string name and the value, you know, it can be an integer, it can be a string. I can plot those. I can pass those as a set of keyword arguments to the plot function using this star star. If I run this, should have temperature isobaric. It's going to be a thick line that's red. And the relative humidity should be in the other plot. It should be a dashed dark green line. There's my thick red line. And there's my dashed dark green line. So using these built-in things, you can make your code, you know, you can use some data structures to actually specify up front how your plotting code should be working. And it makes it real easy now. You know, if I had multiple plots using temperature, I have one dictionary here describing the style, so I can go back here, change, you know, okay, I want, maybe it should be a dark red line. Now, if I do that, all of the plots that were using this same style dictionary could be updated at once. And so you avoid repetition without overly complicating your code.
Yeah, this was really huge when working on my dissertation, and I'm sure with Brian working on his. Or your advisor would be like, hey, you know, we could just make that in fuchsia with stars on it. That would be awesome. Well, that's dumb, but okay, you're the boss. And so you could update it in one spot and turn it loose. Good times were had by all. And it's pretty obvious where you're setting those properties of your plots in your code if you do it like this. And so you don't have to worry about missing certain lines. And you can save a lot of work.
And I know this is some complex stuff, especially for you guys who are just getting into Python. So I apologize if this is a little bit brain frying, but it's just some of the more interesting parts of Python syntax that really helps you write some succinct code that you can still read, but you know, gets it done. It lets you, you know, it took me, granted I've done this a few times, but still it didn't take me long at all to write this out and get a very flexible set of plots here.
So, question.
Yeah.
Is there functionality within the dictionary, or is there a similar function that allows you to do more than just a one-to-one mapping? You take a key and then apply it to a list, or a key and apply it to multiple sets of data?
So you can stuff a list in a dictionary.
Okay.
So and you see already up here, what I did was I made a dictionary within a dictionary. So that could be on the right side of this colon. The values in a dictionary can be anything.
Okay.
And that, without reservation, anything. It's just the keys. Because of the way dictionary works, you can't have the keys changing under it, or it wouldn't be able to find things back again.
I mean, the thing that comes to mind is, so it's something I've struggled with, is if I have a collection of, say, radio sum data, where each of the individual sum launches have different reports at different levels and different numbers of reports, it's impossible to pack that all into an array unless you do something stupid like make sure the array is larger than the largest sum to list, and that the whole thing becomes a ragged pile of nonsense.
Yes. So what you're kind of saying is maybe if you want something like this is another quick way if you want to create a dictionary, just D equals dict, and then D dew point's not really a good example here since they would probably be the same, but oops, what did I do wrong? So that's kind of a.
Okay.
You can make another dict and have it station ID is the key,
Mm-hmm.
and then link to the arrays, or link to the temperature and dew point arrays, and certainly there's the station to the other dictionary would change as you change station.
Okay.
So you have all the flexibility you want. Now you can very easily, you know, create a list inside a list of dicts inside another dict that, you know, you can nest these things arbitrarily that all of a sudden you end up with spaghetti code that is really hard to keep straight, or at least is very brittle if you add a member somewhere in that data structure to do it. So you have all the power you need. It's more of a how do you keep yourself from going insane? But you can there's few limits there.
Okay. And let's say you start getting the dictionary and you just keep adding to it. What if you want to delete something, an item in there?
So we can, for instance, okay, so I have D here. So one option, why are you not letting me in? D dot, there's pop. So what that'll do is that'll pull it out and return it. So now we see D only has temperature in it. You can also, Python has delete keyword, and that literally gets rid of something. In this case, I could say delete D temperature. No return, but if I look at D now, it's empty. And there are a few other methods on there for doing things like that.
Will return the value but delete it from the dictionary.
Yes.
And delete will simply return the value.
And delete in general is for deleting anything. So if I have a variable in my namespace, like if I had this huge array and I wanted to get rid of it and get my memory back, you could use del and give it the array and it'll delete it. So del is a general Python syntax for deleting an object. I don't want it anymore. Get rid of it.
So if you use pop, that means you can't use it again. So if you wanted to make sure you didn't repeat yourself, you would use it.
Correct. So that pop is a free one. Well, dictionaries will work. So if you want to iterate over a dict and continue to remove things from it until you have nothing left, pop's the way you do that. So, any other final questions before we move on to the next one? All right. So the next one we're going to talk about is plotting upper air data with MetPy. So if I go over to my notebooks, there's MetPy units in upper air. And so what we're going to look at is now trying to start using MetPy. It's this package that we've been working on at Unidata for doing meteorology with Python. And so just to jump in and get running, because we're a little bit behind here, we're going to set up the plotting using, grab that display function again so we can repeatedly display the plots, and then set up matplotlib inline. And to get some data, we're actually going to go hit the University of Wyoming's Upper Air Archive. And so what does that look like? So if we go Google for Wyoming Upper Air, there's their page. So we have this web interface where we can click on the station and give it, what do we want from it? And I'm looking, I've got a text list here. And I'm just going to click up here over at Green Bay. And so we get this nice listing, decoded sounding. We're not dealing with the temp format. And so we really want is we just want to grab this part. It'd be nice if I didn't have to copy and paste this to go work with it. Well, luckily we can code that up. So Python has a function to go open a remote URL over HTTP just like it would in a local file. And that lets you just point it at the URL and say read and get the bytes back. I've got a couple other, don't need that one. A couple other functions I'm working with here. So the first thing is I'm going to set up a date time to point to the time of the data I want to grab. So I'm grabbing May 4th, 1999. The site, turns out you don't have to use this code, so I'm going to type in here OUN, Norman. And so programmatically I generate the URL here. I just took a look over here and saw what it formatted. And we have this URL here. But instead of using what it gave me, I'm just going to go in here and programmatically generate it. So I can pull out the year out of my date time and the month and the day. I don't want to get into the details of Python string formatting. But that's what's being used here is Python's string formatting functionality to pull parts of the datetime object out into here, into the string. So what we're doing is just generating that URL string over there. And here I am able to open that URL using URL open and read it. And so if we looked at that, I run it and look at it. There's the bytes. There's the HTML. There's the title tag for the HTML page. There's our data embedded in there within this pre-tag. And then there's some more HTML after it. But then we see the data we're kind of interested in are surrounded by this pre-tag. And so what I do in here is I take the bytes I downloaded and look for the start and end tags. And then I slice the bytes I've been getting using those start and end. And I throw those bytes into something that makes it look like a local file for purposes of being able to pass it to something expecting a file. All this is just a long way I want to blow through of saying, hey, let's go download the data from Wyoming. I'm happy to explain this in more detail to anyone who's interested offline, but I don't want this to be the focus of what we're doing here. Share that print. So we downloaded sounding data from Wyoming. And so we can use, NumPy has a great text parsing utility, gen from text, which allows you to just slice and dice columnar text data with arbitrary delimiters, and you can say, hey, I want certain columns out of that data, and I want to skip some header rows. And so, for instance, I want columns 0, 2, 3, 6, 7. Well, what is that? Well, column 0 is the pressure, 2 is the temperature, 3 is the dew point, 4, 5, 6 is the wind direction, and 7 is the wind speed. So, trying to pull out the basic sounding information here. So we just tell it what columns do we want, and there were a few header rows between the HTML, and over here we saw these, this line of dashes, these other header lines. We just want to skip that to get to the data values. And then this last part, this unpack true, is it arranges the data such that I can do this multiple value unpacking, so that I can get an array of pressure, an array of temperatures, dew point, etc.
Would that be a tuple? Or a list? Or what?
Gen from text is going to return a NumPy array, actually. And so, again, that's the power of some of this unpacking is if the NumPy array is shaped right so that it has 5 rows in it, I can unpack each row into one of these variables.
Skip header equals 6, that's the number of lines you want to
Yes, exactly. I believe there's also on gen from text, there's a skip footer too if you have some at the bottom.
For instance, what if you had a missing value in one of those columns?
If I look at the doc string, this is a Swiss Army knife. I need to run this once so I have it imported. So we look here, you can tell it what missing values look like, and I think you can give it a list of multiple missing values. And in that case, it'll give you a masked array with those values already masked out.
How did you just do that?
So we did get that yesterday. I just realized you weren't here. If you go next to the function call and do Shift-Tab. Yeah, that one's, I forget where I discovered it. I think it was at SciPy last year. That SciPy is a annual conference in Austin for scientific Python users. If this is wetting your whistle, that place is even more scientific Python goodness for about 5 days. So I recommend it. I'll be there. At any rate, I think that's where somebody showed me this and has changed my use of the notebook forever. So download the data. Now we've parsed into pressure, temperature, the fields we want. So MetPy. So one of the things MetPy is based upon is using a unit framework called Pint. Basically, or not basically, but just declaring the units of our arrays. And so what we want to do is take our arrays of data and attach some unit information to them. Easiest way to do that is just multiply by the units. And so we have this units object that's just a registry of different units. We say units dot multiply pressure by units dot mbar for millibar. multiply temperature by units.degc for degrees Celsius, and so on for speed and direction. So what good does that do us having the units? Well, for instance, if we had, we have this variable length and we're saying it's 8 times feet, so we're saying we have a length of 8 feet. If we do math with that, length times length, then we get area with the appropriate units. We do other, maybe a bit more complex. If we had a distance of 10 miles, a time of 15 minutes, we can calculate an average speed. And we print out the average speed, and it prints out in 2/3 of a mile per minute. Well, what does that mean? Well, we could use to base units, and it'll convert to MKS here and give us 17 meters per second. Or we can force it to miles per hour and say, okay, what's that in miles per hour? And that gives us 40 miles per hour. For MetPy's purposes, meteorology in Python, with having a bunch of calculation functions for meteorology, it lets us avoid worrying about the exact units on variables that are being passed into the calculation functions. When we started it, we had these, and we had all these documentation functions where this argument must be in millibars, this argument must be in Kelvin, et cetera, et cetera. And instead, if we just attach units to the variables coming in, we don't have to document all that, and it can make things more robust. So for instance, here's our function to calculate saturation vapor pressure. If I give it a dew point, I'll just get the ambient vapor pressure. So I can calculate the ambient vapor pressure, the saturation vapor pressure, and calculate the quotient of those two and get relative humidity.
So I'm getting a dimensionality here. Probably none of it's in that.
Have you changed something?
I didn't. Not that I know.
All right, when we get to the exercise, I'm going to come back there and take a look at that. So we see when we calculate the various pressures, it came out in millibars. And then when we took the calculated relative humidity, it came out dimensionless. So moving on to try and do SKUTs, first I'm going to sit here real quick and calculate the wind components. That's baked into MetPy. So I can take the speed and direction from our sounding and turn that into U and V. SKUT log P. Anybody not know what a SKUT log P is? Just checking. Okay. You'd be surprised. We have workshops with oceanographers, and plenty of people actually didn't see these before. So real quick, to get a SKUT, if we want one, here's our usual import matplotlib line. We can import the SKUT class from metpy.plots. Instead of using plt.subplots as we've done before to get the fig and ax in one go, since we don't just want an axis, we kind of need a bit more. We just create a figure here. So use plt.figure and just make a figure. And then we pass that to SKUT so it can create the axis it needs and set things up. Once we've got that SKUT, we can start plotting. So we can say SKU.plot pressure against temperature, make it red, SKU.plot pressure, dew point, it's green, add some wind barbs, and SKU exposes the underlying matplotlib axis, so we can get that as .ax. And from there we can say set the y limits and the x limits.
Is there a way with the SKU library to plot the wind barbs, say to intelligently trim them so they're not all over during you can't read them?
It won't, because matplotlib doesn't do a good job with having the hooks to dynamically decimate. We do have a function in there. The name is escaping me right now.
But in MetPy, in the SKU, there's a way.
Not so much in the SKU, just in the general calculation function. It has a function to like intelligently. If you gave it a list of pressures you wanted them for, it would find the closest ones for you. So you could just say maybe plot the mandatory levels,
Right.
and it would figure out what of the winds is closest to the points you asked for, and you could then plot that with U and V here. So you'd have to do the part of decimating, or the part of reducing the number of points.
To find the levels you want.
Yeah, exactly.
I'll look at that.
And if it's not, it'll be documented. Whether or not there's a good example so that you know it exists, I'm not clear of right now in my head.
You know, off the top of your head, if the curve blades are just
Nearest.
fixed.
So that's a basic SKU plot, but what of course we really want on here are some of the special lines. So SKU can plot dry adiabats, moist adiabats, and mixing ratio lines. So we can add those to the plot. MetPy also has an LCL calculation as well as the dry lapse rate, so we can calculate the LCL from the surface point, calculate the temperature of the LCL, and then add that as a black dot on the plot. If you really want to go all out, MetPy also has a parcel profile function, which will lift from the starting point dry up to the LCL and then go moist adiabat from there. So now there's your ascent profile.
The one in black?
Yeah. And then since we're using matplotlib for plotting here, we're all baked into that directly. We have all of matplotlib's plotting, including its fill routines, where it can fill the area between two curves. And so using that, we can actually shade the positive and negative area on the sounding. Or since matplotlib has a function to plot a horizontal or vertical line that always spans the full plot, we can use that. Our vertical lines are the skewed temperature isotherms. And so we can use AX-V line, axis vertical line, to highlight certain isotherms, like the 0 degree isotherm.
Just return some interesting quantities too, like mixed layer cave, surface space cave.
It doesn't return those. The functions, the calculations aren't yet in MetPy. Those are on the extensive to-do list. Would love it if someone contributed them open source, but I know how that goes. But it's on the list. We just haven't gotten there yet. And that's definitely one of the things I want with the units, is that way I can be sure what cape is coming out. The energy should just fall out of the calculations with all the units correctly specified and things like that. So the big thing holding that up has been getting the level of free convection and equilibrium layer calculation in there robustly. So yeah, now it's time to get hands-on. I mean, I just ran through those, but it's kind of just demoing the different features that you have available there. So now it's your turn to go make a SKU of your own. I'd either come back up here and change, the date and station, or copy and paste that to your block down there. But just change your date and station here, and have either today, yesterday, or a date of your that offhand, and play with making a SKU. Make the basic plot, maybe add some special lines. You can play with the LCL. We've got some time here to play with this. Any questions before you guys get going on it? All right.
not sure. I was gonna ask him to do it.
All right.
I was gonna suggest a comma clean all. Do fresh data. Neutral orbit, because I don't know how to update the environment.
You guys are so familiar with like sharp time.
Yes.
Yeah, it's pretty cool, but I found it's like really slow if you want to do more than just like a couple hundred.
Okay.
I don't know if you guys have tested it out.
I haven't played with it much.
But yeah, what we want to do is get all these connected indices for something like the RAP.
Mhm.
Tens of thousands of data points, so it's just kind of slow. But it's the way I'm using it now.
Yeah, my goal would be to have MetPy be able to do those fast.
Yeah.
And I'm not sure if it could do it today fast or not. But if you
No.
kick the tires on it and find it too slow, let us know. Because right now everything's pure Python. But
I'll take a look at it. Yeah, it's gonna be really nice.
and I have talked actually to them and then Patrick Marsh at SBC. We've been trying to push getting the library that underpins N# calculation library, get that out there as a C library we can all wrap and take advantage of it that way, get the speed and verify calculations. So that's been talked about. No actual work has been engaged in that way yet.
Is there a library different than what ships with sharp enablers?
I thought so, but I've been getting some Patrick at this point.
Cool. Yeah, that's.
I was gonna say, that's on GitHub. I wish I would do more.
Was that all N#? Did someone jump back there?
Yeah.
Yeah. We're off schedule, buddy. We're into what's supposed to be break right now, right? Yeah. Okay.
Yeah.
I think N# are different. I don't think it's all, but I don't think Genpack is all those things that N# is. Why not? Specifically, N#. Score ships with that doesn't mean it's just N#. Oh no,
Small constants, some arbitrage.
So you do the, say, give the pressure, so
Okay.
I wanted to expand all my.
Gotcha. So another way to do that would be if you did the skew.ax h1, or axis horizontal line, axis spanning horizontal line, and just give it the height. So give it that.
Just one. And I'll do it somewhere else.
Okay, and then function.
Oh, sure. you go. Now you could also then
So I can modify it for them. Like we did down
okay, so x dot, yeah, so the V line fault temperatures vertical over skew, H lines, horizontal. If you want the handle, you just,
Or I can just specify all this stuff.
yeah,
All.
yeah. You could get the handle if you saved it off there, or Axe, I think, has a lines attribute or something that's a list of little lines. I think. Okay. It has something like that, I just can't remember. It's probably easiest just this run. I remember this being asked at the last workshop, but I didn't show it here. But there are photographs as well that do this that we don't have in this example, but are in MetPy's examples.
I think you did end up drawing one. You said there was a way to tint it up right at some point.
Yeah, I forget how to work. I have to look at the examples.
Yeah.
So.
It doesn't change the size of the images.
Cartipy's a better interface. Yeah, and it's sponsored by the UK Met Office. Okay, so I think it's probably the future. I think even Jeff Whitaker did BaseMap. He's not doing much on BaseMap these days. Okay, seems to be Cartipy has the momentum behind it. Which handles things a lot. Handles many things better. I don't know if it does everything BaseMap does, but we've been able to move our workshop over much.
I might try to switch that. I just started BaseMap. So
You just started. Give it a try.
I mean, I just started, meaning like years ago. I started using BaseMap without asking any questions, and I've just been using it forever.
And even 2 years ago, the answer might have been different.
Right.
My brother, where I'd go right now.
That's fine. Yeah, cool.
If there are any problems, feel free to reach out to us.
Yeah, definitely. Thanks for doing this. This is really cool.
Hope the morning wasn't too rough.
No. I didn't come yesterday because I've been using stuff. But just to even like, that you guys have all the notebooks and all that stuff, that's super cool.
And we have online documentation for MetPy and Python called Read the Docs.
Yeah. Is it, what, are you guys familiar with there was like students at OU that came up with that SharpPy module? Is that, how much different?
So just SharpPy is more of a whole end-to-end GUI program.
Right, it's a GUI that pops up. With MetPy, you go get this PT.
We're trying to be, like if you know sci-fi for meteorology, we're trying to have reusable calculation functions you pull out and use how you need to.
Right, okay, right, because that was, when I was using that, it was like you can only pick certain options, there's not as much flexibility.
I mean, in an ideal world, you feel something with Sharpie on top of it.
Right, or be able to,
But both things exist now, so.
right.
So we're trying to go MetPy there. I guess replacing Genpack, but having Genpack available as easily in Python, all the functions, all the tools, all the plots.
Okay, so MetPy is almost a generic.
In
In
the scripting world.
Okay.
But I always think of Genpack as a thing that's just there, that you don't necessarily pull in for arbitrary research. Things you're doing, whereas MetPy should be a repository of reusable tools.
Awesome. 28 or so functions.
Yep.
Okay. I have no idea. It was kind of changed since it was first checked in 2013. I think that's one I'm going. First click. I don't know if that's what they was.
I don't know.
But I can almost guarantee whatever SBC would do, it would follow the same sort of function role.
Yeah, I'm sure. I just don't know if it's the same. Theirs, I mean, they're very attached to their.
Sure. I think I sent that to you. Well, I did. So that's accurate. So it's supposed to be going back and going to that video. Actually, let me get. Let me do it. It's not done. Still not done.
That was fun.
Yeah, that was pretty catastrophic. Kind of.
Yeah.
Fit over.
It did. Well, it's, there was a mismatch between packages or something. And they built the package. So.
Maybe they should move to Conda.
Well, let's see, Conda, it wasn't Conda Ford built the packages with mismatched stuff, so that's what went.
Oh, Conda built it.
The HDF5 package came from Conda Ford.
Okay.
So silly as it sounds, could you add a legend to SQT?
Yeah.
How would you do that?
skew.ax.legend. So the skew.ax is the same ax object.
As my math problem.
Exactly. Skew essentially wraps for applying the proper transform for doing the skew stuff.
And then you have to figure out, you have to feed it info. So
Yeah, I mean, if you called plots, in theory, if you called plot and added labels, so when you do the plot for temperature and dew point, you could pass it a label keyword argument. That would make it real easy to get legend for these.
Okay.
I just replaced the. That's not you, Carter.
Yeah.
Somewhat simple question. How can I get all the possible functions in SKU module?
Skew.tab. There we go. I'll do my first try.
No, sorry. Hit the tab key now.
Watch it once I get this.
Okay, how about
Skew.star question mark. So I think we talked about if we should. There we go. Oh. So the double underscore ones you can ignore safely.
That doesn't give me everything. Or
that gives you everything that skew has. If you want everything that's on ax for more options, so like skew, that's just giving you what we put in MetPy split from skew. So you dot, yeah, now show that. Now you'll have a lot of this.
So what am I doing wrong here with SKU legends? I put in a couple labels
Okay, that's good.
and.
Skew.ax.legend is a function.
Oh.
So if you just call skew.ax.legend. Open close. Sorry, just put open close brain on the end of it. So we're going to call that legend. There you go. That's good. Now I'll try it.
Cool. Okay, and then I can put center on that. It's okay.
I don't know that there's anything like that available. Station numeric ID.
No, I'm not trying to embark on that. We don't have a data source.
Oh.
No.
still working on getting the data that are coming across Node into NCDF instead of dealing with the horrible temp format. So yeah, I don't know. Since I haven't had data, I haven't had to make a staging map yet.
So go from Unidata and go to MetPy. Use the docs.
What is it?
Org or IO should both work right now. I think IO is the way of the future.
Oh, we keep displaying it. In the shortcut, and then have you center a legend. Read the docs.
Okay, so when you call legend, give it a keyword argument of loc for location equals
And then parentheses center.
quotes. Probably needs to be upper space center. I bet center would probably put it in the middle. Oh no, sorry.
Oh, you're talking.
The word upper space center.
Underscore
Space. Yeah.
Oh,
I think that'll do it.
Ah,
Ha! I've been doing this for a decade now.
That's so cool.
Those are the words I like to hear.
Do you have any examples for satellite imagery?
We're doing that after lunch. It's Genie file. It's not like a area. I know you guys right here.
Oh, you're talking radar data, or is it?
There's a Genie. NOAA port has Genie formatted satellite imagery from GOES.
Okay. So, does that seem to be variable?
Okay. I've made sure we're filing the test GOES-R products to this, but I've not tried to slot any of those yet. Unidata will have a ground station up there, so we'll have the full GOES-R in Boulder as well. So I'm sure we'll be playing with that when it's available.
Hopefully, we can figure out how to help with each iPhone.
Cool.
We have that at Unidata.
Good.
Yeah.
Load up here.
Whoa.
Okay, good to see you're not creating a new one, probably. So
I just want to like delete try to not remove the legend.
I think that, well, I think actually the best way to get out of this is just go up and yourself to where you're. Run that again.
Find a few nuggets of run that.
You're just reusing the same figure over and over. That's a danger of the notebook and how we have to step through. When I'm writing code, the plot goes in one cell.
Yeah.
It's really only for these teaching ones. It's like, oh, we added this to the plot.
Right.
We added this.
Hanging in there still.
Sean, understate?
No.
Oh, okay. Okay, so we haven't imported it. Go up higher. Up. Need to run that cell.
Oh, this one.
Yep.
So every time I use it, I can go back and run.
Yeah, or generally, you can use things like the cell menu. Cell menu. You can say like run all the cells above or run all the ones below this one. It's a frequent problem with notebooks that you get things run out of order. So far, I've not seen a good way to address that. I think we'll move on to Sean's notebook at about 10 after, so kind of moved into break here, so if you want to go ahead and break or keep playing, whichever you prefer.
You guys made progress on it. So last time we did MetPy. Yep, there wasn't much up there.
Yep.
Or I wasn't looking in the right place.
Well,
There have been multiple times in the last year where the docs were failed to build silently,
Oh, so there's just nothing up there.
or there's a half-built copy up there, and it's only, oh, wait, what happened to my docs?
Sure they got.
I fixed that so that I tell